This is our second review video for Chapter 4, where we're working with quadratic functions. So in Section 2, we wanted to learn how to graph quadratic functions written in either Vertex or Intercept form. So again, we're taking a look at the chapter summary on page 319 this time, and I chose to take a look at numbers 8 and 12. So for number 8, they give us the equation y equals x minus 1 times the quantity x plus 5. So as you can tell, this is written in Vertex and Intercept form, y equals a times x minus p times x minus q. Okay, so in Intercept form, the four things we want to take a look at are, number one, we first find the x-intercepts because those are easy to find right off the bat. So the x-intercepts are going to be p comma 0 and q comma 0. Now the next two things, again, they go together, are going to be the vertex and the axis of symmetry. Okay, and then number 4, we're just going to have to find another point. Now, for the vertex in this problem, we do have a formula just like we did in the other equations. So to find the x-coordinate, the formula is p plus q over 2. So remember, it's just the average of the x-intercepts because it's symmetrical. So using that, we go back up to here. And in our problem, notice our p comma 0, our p is going to be 1, and then our q is going to be negative 5. Now, some of you might have been confused where I got that. So remember, in reality, what's happening with both of those is you're setting them equal to 0. So when you solve it, you get x equals 1, and you have x plus 5 equals 0, and you have x equals negative 5. So that's where we get p is equal to 1 and q is equal to negative 5. So going back to our vertex formula, we have p plus q over 2. So we're going to have 1 plus a negative 5 over 2. And that's going to give us negative 4 over 2. So that's going to give us negative 2. So remember, that is our x-coordinate of our vertex, which also gives us the equation for our axis of symmetry. To find the y-coordinate, we simply substitute that back into our original equation. So we have y equals negative 2 minus 1 times negative 2 plus 5. So substituting that in and simplifying, we have y equals negative 3 times 3, and that's where we get negative 9. And that is our y-coordinate. And then we need to pick another point to graph. So I'm going to assume that negative 1 might be a good point to pick. I don't know why. It just looks like it's close to my vertex. So substituting negative 1 in, we're going to have negative 1 minus 1 times the quantity negative 1 plus 5. So we have y equals negative 2 times 4, and that's where we get y equals negative 8. And that's basically it. So now we go to our coordinate plane. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so our first point, we're going to graph our x-intercept. So we have 1, 0. And then we have negative 5, 0. 1, 2, 3, 4, 5. We have a vertex at negative 2 and negative 9. We have our axis of symmetry, which goes through that x-coordinate of negative 2. We have our extra point of negative 1, negative 8. And then by symmetry, we also have the point negative 3, negative 8. And then we have our parabola. Oops. If I could make it go through those points, that would be nice. And there you go. Now let's take a look at graphing number 12. So we have the equation f of x equals the quantity x plus 6 squared plus 8. So again, this is written in vertex form. It's in the form of a times the quantity x minus h quantity squared plus k. So with this form, the first step you're going to find is find the vertex, because that's easy to find, and that's given to us as the point h comma k. Now looking at our equation, our h is going to be negative 6. Remember, it's the opposite inside the parentheses, and positive 8. Now step 2, we're going to find the axis of symmetry, because that always comes directly with the vertex. And then we have the axis of symmetry as x equals negative 6. And then for the vertex form, what I recommend doing is finding an additional point. So for number 12, sometimes it's easy to find a y-intercept, and then sometimes the y-intercept is really large. So you just really need to find another point. Okay, so that's all I'm going to do for this problem. So finding another point here. So let's pick a value close to negative 6. So let's pick the value negative 4, only because I've done this earlier, and I think that's going to work nicely for us. So substituting in negative 4 into my function, we have negative 4 plus 6 squared plus 8, and that's going to give us 2 squared plus 8. So that's going to give us 4 plus 8, and that's going to give us 12. That looks good to me. Okay. Again, pulling all this together, so we're going to do our coordinate axes, and it looks like we need to go at least 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so our vertex is at negative 6, 8. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So I hope that's where it is. Negative 6 is our axis of symmetry, and I hope it goes through that point. And then we have negative 4, 12. I think I went a little bit over here, but 1, 2, 3, it's 8, 9, 10, 11, 12. So it looks like something up here. So I think we get a parabola that looks something like this. And that is how to graph in vertex form.